Take this paper towel roller. Spin it on a lathe. The whole lining spins. Surely you'd never say the hole spins?
Why not?
Even though the hole might continue to be entirely filled with a dowel that didn't spin or move at all?
What difference does that make?
None. Really. But now I have you. Take a toilet paper roller, put it inside the paper towel roller, and spin it the other way. The big hole spins clockwise. The little hole spins counterclockwise. But the little hole is part of the big hole, so it spins clockwise along with the rest of the big hole. So if holes can spin, as you think, the little hole turns out to be spinning in both directions at once, which is absurd.
I see why you might think that the little hole is part of the big hole, but you can't expect me to agree. The little hole is inside the big hole, but that's all. Hence I have no reason to say that the little hole is spinning clockwise.
Consider a thin-walled hole with a gallon of water inside. The volume of the hole is at least a gallon, whereas the volume of the whole lining is much less. If the hole is the whole lining, then whatever was true of one would have to be true of the other. They could not differ in volume.
For hole, read bottle. For whole lining, also read bottle. You have the same paradox. Holes, like bottles, have volume, or, as I'd rather say, are voluminous or equivoluminous with other things, in two different senses. There's the volume of the hole or bottle itself, and there's the volume of the largest chunk of fluid which could be put inside the hole or bottle without compression. For holes, as for bottles, contextual clues permit us to keep track of which we mean.
What is the volume of the hole itself? How much of the cheese do you include as part of one of these holes? And how do you decide? Arbitrarily. That's how. Don't try saying you include as little of the cheese as possible, for however much you include, you could have included less.
What we call a single hole is really many hole linings. Some include more of the cheese, some include less. Therefore I need not decide, arbitrarily or otherwise, how much cheese is part of the hole. Many different decisions are equally correct.
How can a single hole be identical with many hole linings that are not identical with one another?
Really, there are many different holes, and each is identical with a different hole lining. But all these different holes are the same hole.
You contradict yourself. Don't you mean to say that they all surround the same hole? Whereby, surround, I mean, surround. Not be identical with.
Not at all. I would contradict myself if I said that two different holes were identical. But I didn't. What I said was that they were the same hole. Two holes are the same hole when they have a common part that is itself a hole.
You agreed before that there were as many holes in my cheese as crackers on my plate. Are there still?
Yes, there are two of each left.
2 crackers, to be sure, but how can you say there are 2 holes?
Thus, there is a hole, and there is another hole, that is not the same hole, and every hole in the cheese is the same hole as one or the other.
Be so kind as to say, co-perforated, not, same. And stop pretending to talk about identity when you are not. I understand you now. Co-perforation is supposed to be an equivalence relation among hole linings, and when you say there are 2 holes you are trying to say that there are 2 non-identical co-perforation classes of hole linings. Really you identify holes not with hole linings but with classes of hole linings.
I would if I could, but I can't. No, holes are hole linings, but when I speak of them as holes, I find it convenient to use same, meaning, co-perforated, wherever a man of your persuasion would use same, meaning, identical. You know my reason for this trickery. My sentences about sameness of holes will be true, just when you wrongly suppose your like-sounding sentences to be. The same goes for sentences about number of holes, since we both analyze these in terms of sameness.
You still haven't told me how you say there are as many holes in my cheese as crackers on my plate, without also saying how many there are.
Here goes. There exist 3 things. X, Y, and Z. X is part of the sum of the crackers, Y is part of the cheese, and Z is part of Y. Every maximal connected part of Y is a hole, and every hole in the cheese is the same hole as a maximal connected part of Y. X overlaps each of the crackers, and Z overlaps each maximal connected part of Y. Everything which is either the intersection of X and a cracker, or the intersection of Z and some maximal connected part of Y, is the same size as any other such thing. X is the same size as Z.
Your devices won't work because coperforation is not an equivalence relation. Any two overlapping parts of my cheese have a common part that is a whole lining, though in most cases the whole lining is entirely filled with cheese. To be coperforated is therefore nothing more than to overlap, and overlapping is no equivalence relation. The result is that although, as you say, you can find two whole linings in this cheese that are not coperforated, you can find another one that is coperforated with both of them.
If you were right, that a whole made of cheese could be entirely filled with the same kind of cheese, you could find far more than two non-coperforated whole linings, and there would be no such thing as cheese without holes in it. But you were wrong. A whole is a whole, not just by virtue of its own shape, but also by virtue of the way it contrasts with the matter inside it and around it. The same is true of other shape predicates. I wouldn't say that any part of the cheese is a dodecahedron, though I admit that there are parts that do not contrast with their surroundings, that are shaped like dodecahedra.
Consider the paper towel roller. How many holes?
1. You know what I mean, many, but they are all the same.
I think you must say there are at least two. The left half and the right half are not the same hole. They have no common part, so no common part that is a hole.
They are not holes, they are two parts of a hole.
Why aren't they holes themselves? They are singly perforated and they are made of matter unlike the matter inside them. If I cut them apart you'd have to say they were holes?
Yes.
You admit that a hole can be a proper part of a bigger, say thicker-skinned, hole?
Yes.
You admit that they are shaped like holes?
Yes, but they aren't holes. I can't say why they aren't.